Guys, so today we are going to look at 4.3 properties of logarithms. So we looked at the exponential function, we looked at the logarithmic function, we saw how they were related, and today we're going to look at some properties of the logarithmic function. So let's get started. This goes over the product rule of the logarithmic function. It shows that if you're multiplying two values inside of a log, then you're actually adding those two values. That makes perfect sense, right? Because if we think about our exponential rules, if we were multiplying two values that had exponents, we'd actually add those exponents. So it's very related here as far as the properties. So same for quotient. Oh, let's take a look at these. So if I wanted log, and we know when it's not written, it's the common log. So if we wanted log of 8 times log of 6, that means the operation we're doing is log of 8 plus log of 6. If we have log 0.2x, that means we're doing log of 0.2 plus log of x. If we have a log base 3 of 3xy, we could write that as log 3 of 3 plus log 3 of x plus log base 3 of y. And we know that log 3 of 3 here becomes a 1. So then our final simplification here would be 1 plus log base 3 of x plus log base 3 of y. So just keeping that idea there. So let's go on to the next one. The next is the quotient rule. You can see it works a lot like the multiplication rule, except for when we're doing division, we're actually doing subtraction. And again, you know that this makes sense because when we did exponentials and their properties, it's the same idea there. So if I wanted to rewrite this one, I could write it as log 17 of 4 minus log base 17 of 7. This one here would be ln of r minus ln of x. The power rule says that if we are taking our value inside the log to a power, we can move that power to the front and end up multiplying by that log. And so let's look at this one. If I have log base 3x of 4 is my power, so I can do 4 times log base 3 of x. So it becomes a coefficient essentially in the front. Same thing here. If we have negative 8, this would be negative 8 log of q. And here, if we have the fourth root, we know that's the same as saying log base 2 of x to the 1/4 based off of our root exponent rules, which then we could write as 1/4 log base 2 of x. So we can still deal with it even when we're looking at a root. All right, so this just reiterates those properties that we just went over so that you have a summarized list of how they work. So if we wanted to express in terms of sum and difference of a logarithm and extend it completely, we can start by doing the division that goes here first, right? We know that this division sign would lead us to write this as log base b of p squared q to the 7th minus log base b of m cubed b to the 7th. So we can break that up further by dealing with the multiplication in each one of those logs. So then this could be written as log b of p squared plus log b of q to the 7th minus this minus is going to be applied to both of these. So think about that, right? So this would be log b of m to the 3rd plus log b of 7. So we can distribute that negative to where it's in both terms here. So that's log b of p squared plus log b of q to the 7th minus log b of m to the 3rd minus log b of b to the 7th. I lost my b up there. Okay. So now that we've distributed that completely, we can rewrite it as an exponent with the exponent rule. So we're bringing those exponents to the front. So we have 2 log b of p plus 7 log b of q minus 3 log b of m minus 7 log b of b. And we know that this log b of b is simply 1. So 7 times 1 would just leave a 7 right there. So we'll end up with 2 log b of p plus 7 log b of q minus 3 log b m minus 7. And so that is completely expanded and then simplified. All right, express the terms of sum and difference of logarithmics, expand completely. So same thing here. We can do the same thing. This would be log of 5a minus log of 4b squared. So then our next step here would be log of 5 plus log of a minus log of 4 minus log of b squared. So I just went ahead and distributed that negative log there because I knew I was breaking it up into addition, but that log is going to be distributed, so I went ahead and did that. So then I can do that exponent rule. So I get log 5 plus log a minus log 4 minus 2 log b. So if we're considering these logarithmic expressions, we went one direction, we can also go the same direction, the opposite direction. So we went from multiplication to addition, but now we can go from addition to multiplication and so on. So let's do a few like that. So if we want to express this as a single logarithmic, we would look at this and we see we have log of 1,000 minus log of 10,000. So we have that minus, which means we have log of 1,000 over, I said 10,000, but it's 100. So then that would be the same thing as saying log of 100 or 1,000 divided by 100, which would be 10. And then we know that this is the common log, right? So we know that there's really this base 10 down here. So if we're doing log, common log of 10, that's going to equal 1. So for this next one, we can kind of reverse engineer here, right? We're going to pull any of the coefficients to the front or as an exponent. So we get log b of x to the 1/4 plus log b of y to the 4th minus log of b base b x squared. So then from there, we can now deal with the addition and subtraction. Those being added there would be multiplied when they're brought together. And the one being subtracted would be put on the bottom in division, right? So we get x to the 1/4, y to the 4th over x squared. So if we wanted to express these as a single logarithmic, so this would be log of 25 times 4, which would be log of 100. So this is base 10 here, if it's the common log. So to go from 10 to 100 with exponents, we would take it to a power of 2. So here we would have ln of that subtraction. So we have 7x plus 6 over x. And we can't simplify that, so we would leave it as is. And then here we could first change this to ln of x squared plus ln of x minus 2. And then with the addition, we can multiply. That would be ln of x squared times x minus 2. So then we can distribute ln of x cubed minus 2x squared. And so that would be as far as we go on that one. Express as a single logarithmic, and if possible, simplify. So same thing here, we have the minus here, so this would be log of x squared minus 25 over x minus 5. Well, we know x squared minus 25 can factor. So we get log of x squared minus 25 is the same as saying x plus 5 times x minus 5 all over x minus 5. And so those x minus 5s cancel. And we get log of x plus 5. So there is one more property that is really helpful, especially if like you didn't have a calculator. It's called the change base property. And this is where you can change the base to make things easier to work with. So for any logarithmic base a and b and any positive number m, you can write log base b m as log base a m over log base a b. So let's look at some ideas here. So you can again look at it with the common log or natural log. It works regardless. With common log, you could be using base 10, right, as your base here to change it. So let's take a look. So for example, if you wanted to solve this and your calculator only has the ability to do log base 10 or be able to do the natural log, then you could do the change base formula here and get a rounded numerical answer. And so that is it for 4.3. Next time we're together, we'll work on 4.4.